This question here, right? A man swims across at 3 kilometers an hour across a river 125 meters wide. So here's our river here, and the man is setting out to travel directly upwards. Okay? The river is flowing at 5 kilometers an hour. How long will it take him to swim as to reach the opposite bank as quickly as possible? Well, the truth is, if you're swimming at 3 kilometers an hour, there is no component that will beat the 5 kilometers an hour going to the right. So what you know is you're getting swept downstream, like it or not. You're going to end up downstream somewhere, no matter what happens. Now, anytime you're asked to do it as quickly as possible, what you're going to do is you're just going to say, okay, I'm going to aim my 3 kilometers an hour directly up, and your 5 kilometers an hour is going to drag you to the right. So your speed is going to be technically, now my axis is, because of the way I set up the question, it's going to be 5i plus 3j. Yeah? You could also draw a similar type, you could draw this diagram vertically downwards. You'll have 3i plus 5j instead. Okay? Depends on what way you draw the diagram. Now, what I'm just saying is up is I and right is j. Now, it goes, he wants to travel 125, so this is how much he travels per second. I'm going to use Pythagoras' theorem and find out how much distance he covers. Actually, I don't even need to do that. Also, I need to know is that he's going 125 upwards, and he's going to cover 3 every second. So what's 125 divided by 3? Sorry?
3 kilometers.
41. There's also an adjustment to be made here, because it's not meters per hour, it's kilometers per hour. So we're going to do. We're going to do 0.125. We're going to change meters into kilometers. So 0.125 divided by 3, and what will that get us?
0.0416 or 150 seconds.
0.0416 hours.
2.5 minutes.
Yeah. Or 2.5 minutes, yeah? 2.5 minutes once you divide that by 60. Okay? To get turned into minutes. Very easy question. You're on the board. Okay? Now, the next question, not so easy. So, what we're going to do is we're going to write down quickly a list of what we know. What we know is that we'll call the man the swimmer. Velocity of swimmer is, anybody remember, let me see. Yes, okay, I understand this now. So, velocity of river is going to be, what's it, 5. Velocity of swimmer is 3. Okay. Now, are we doing phi SR? So we're doing velocity of swimmer relative to the river. Now, actually, as it turns out, this is phi SR is 3, not phi S. Because phi S is the speed the man actually does relative to somebody who's looking at him along the river. So, for example, a swimming race where I could swim 3 kilometers an hour in still water, but yet the river is flowing at 5. To the observer here, he's going to be observing me swimming at 8. Okay? So in this really simplified version, phi S would be 8 and not 3. Okay? So what we're going to do here is we're going to write down magnitude and direction. So we're going to do phi SR. Velocity of velocity of swimmer in the river is phi S minus phi R. I'm then going to rearrange my equation to have phi S equals phi SR plus phi R. Now, for anybody who's been in the last while, you'll understand that I'll always make a list, and I need 4 of them to do it properly. If I only have 3, there's going to be a biggest angle part to the question. Okay? So you'll understand what I'm talking about now. Now, what I call this is magnitude, and this one's called direction. Okay? Magnitude of phi SR is, anybody? Phi SR? 3. Match of the river. 5. Okay. I need one more.
Yeah, the direction of the river.
Uh,
The direction of the river is going.
to go as little downstream as possible, okay? I know the direction of the river is what Jack said, it's going directly east, okay? I have 3 out of the 6. When you have 4 out of the 6, you do cosine rule, sine rule, no tricks. You can get every angle, every length, no bother whatsoever. In the case like this, you're going to come up with something called biggest angle to maximize your loss or minimize your loss. You'll see it now, okay? So what I'm going to do first of all is, when I'm drawing this out, which 2 am I allowed to start at the same point? I'm allowed, phi s is, so I have a starting point. Phi s, let's say, comes out of there. I'm only allowed to choose one of these to start at the same point. Ideally, I should probably choose the maybe the river. River would be a good idea, and the river's going east, okay? So, let's, using our common knowledge, if this is the starting off point, as a swimmer, now I'm talking about phi SR here, am I going to aim left, up, or across? I'm going to aim left a little, in the ideal world, to see if I can combat the river's current, okay? So, that there, I'm going to set off to the left slightly. I'm going to call that phi SR. Okay? Now, I have a choice. Oh, it's alright. I've actually used phi SR instead. Right? So I use phi SR to the left. That means I have to join the starting off point with phi S. Okay? So phi S is going to go, we know we're going to get dragged downriver, right? So we're going to get dragged down here somewhere. And then finally, phi R is the one that goes up on the top. Okay? So phi SR, phi R. Now, those of you who, some of you might have drawn it differently, and you can draw it differently in another way. What some of you might have done was, you might have said, okay, you said I had to start phi S and phi R at the same point. Some people would start phi R right away, and then they'd say, okay, phi S is going this way, and then you have phi SR going the other way. The only difference between the 2 triangles is that one of them is, they're upside down versions of each other, aren't they? That's phi SR, and that one there is phi S. Okay, so they're just different, they're the same triangle, but just written slightly differently, okay? These are the only 2 triangles you're allowed. Now, upon completion of this, okay, what we're now looking at is numbers. The only 2 numbers we have are 3 and 5. 3 and 5. Okay? When you're in this scenario where you have no angles and only 2 sides, what you always have to do is you always have to use the angles opposite the information. Call this angle X, call this one angle Y. And what you're going to get is sine Y.
5 is V.
Sorry?
5 is V.
Oh, sorry, 5 is phi R, excuse me. You're right. Phi R is 5. So, what we're going to say is this is angle X and angle Y. You're going to say sine Y over 5 equals, and now this angle here is going to be X. Sine X over 3. Now you're at this stage. Now what I've learned off by heart, without even understanding it, is, sorry lads, one of these is going to be turned into 90 degrees. Always happens. When you have 3 pieces of information out of 6, one of them always turns to 90 degrees, and your plan is which one should turn to 90 degrees. Now here's the way I have it learned without understanding it. The way I have it learned is, if I move the 3 up, I get 3/5. You're allowed sine inverse 3/5. That means it's the correct move. If I was to bring the 5 up, and I was to say, okay, well then I'd get 5 over 3. I can't sine inverse 5 over 3. That's how I know that's the wrong move. Okay? Now, more important than that, what can happen next is, what can happen here is we can basically say this, alright? See this angle here? That angle there is phi, that's phi s, isn't it? Going downstream. That's phi s. The bigger angle x is, do you see the way angle x is alternate to that angle there? The bigger angle x is, what happens then? The bigger angle x is, the steeper this angle is, and the less you travel downstream. The smaller angle x is, the further you travel downstream. In a test that's very confusing, I would just advise you to cross multiply and see which one you can actually sine inverse. Every single time it always turns out to be one that you can't sine inverse and one that you can sine inverse. Now that you've decided on that, what we're then going to do is we've decided that we can sine inverse 3/5. So sine x equals 3/5 sine y. Now we all know that the sine function, the bigger the angle, means the bigger the number, the bigger the sine angle. So when is sine y at its maximum value? Can anybody tell me? Sine y equals its maximum value of 1 when y equals 90 degrees. This in turn means that sine x equals 3/5, and this in turn will mean that x equals sine inverse 3/5. And what is sine inverse 3/5? Anyone know sine inverse 3/5? Is it 36.87 or something like that? Is it? Okay. 36.87 degrees. So now you know that that's, if we rub all this out for a minute, that's 3, that's 5, I said that that's 90. This one here is 36.87. And this one up here is 53.13. What does the question want to know? How long will it take him? Okay? How long will it take him? Now, what we don't have is to find out how long it will take him. Okay? What we have to do is, we know what phi s is. We actually have to find out what phi s is. Okay? So how do we find out what phi s is? We can use the sine rule, can't we? So to find out what phi s is, what we can say is phi s over sine 53.13 equals any other side. So let's say 5 over sine 90, because 5 over sine 90 is quite an easy one. Phi s equals 5 times sine 53.13. And what is 5 times 53.13? Is it 4?
3.9999.
Oh, sorry, 3.999, which rounds off to 4 meters per second. This means that we are going 4 meters per second every second. We need to now break it up into its horizontal and vertical components, because we want to figure out, we're going upwards at 125 meters. So if we get the vertical component, we can just divide 125 by the vertical component. So what is the vertical component then? That's 36.87. We call the vertical component h. H equals sine 36.87 equals h over 4. And when you gave me the answer there, Dan, for sine 36.87? 2.4. H is 2.4 meters per second. To get the time taken, we're then going to have to divide that's kilometers per hour, isn't it? And not meters per second. So it's kilometers per hour. So it's 0.125 divided by 2.4, and what do we get? 0.052 hours. Or multiply with 60 to get 3.125 minutes. Okay, guys.